Algebra 2 students, this is your statistics and probability review. In problem 1, it says for the following data set, calculate the population mean, standard deviation, median, and z-score for x equals 3 and for x equals 6. Round answers to 2 decimal places. So pay attention to directions like that. 2 decimal places. Alright, so you're going to need to put all of this data in the lists in your calculator. So on your calculator, you press Stat, and you want to edit your list. And if you have data in your list, you can clear it out, and then you need to enter all of those numbers. After, you can pause the video here, because you should really practice putting those numbers in your calculator. And then after you have the data in your calculator, you're going to press Stat and go over to Calculate, and you want one variable, Statistics, which is choice 1, and enter. Okay, so normally the mean, normally the mean is represented with mu, like this, but on the calculator it's represented with x and a bar on top. X bar. So let's go back and see what that number was. It was 4.81. Okay, standard deviation is normally with a sigma, and in this case it's with sigma x. So let's look back at the calculator. Sigma x is 1.27. Alright, median. The median is also on that screen. We just have to scroll. So I don't see it yet. I'm going to scroll down. There's minimum, first quartile, median. So the median is 4.8. Alright, and then we need to find 2 different z-scores. One for when x is 3, and another one for when x is 6. So let's do x is 3 first. Remember your z-score formula is, let's go back to black, z equals x minus the mean over the standard deviation. And the z-score tells you how far above or below the mean a data point is. So in this case, we have x equals 3, so we're going to do z equals 3 minus the mean, 4.81, over the standard deviation, which is 1.27. Okay, and if you put that in your calculator, take a minute to do that, you should get negative 1.43. Okay, and then for x equals 6, we need to find the z-score. So that would be 6 minus 4.81 over 1.27. Okay, and so you put that in your calculator, and you should actually, well, let's just try it. 6 minus 4.81, enter. And then divide that by 1.27, and I get 0.94. Alright, from the normal distribution graph to the right, estimate the mean, median, mode, and standard deviation. Okay, so when data is normally distributed, like you can see here on the bell curve, then your mean, median, and mode would all happen at the middle, which is 60 in this case. So the mean is equal to the median, equal to the mode, and they all happen at 60. The standard deviation is how far the data point is to the next line. So this distance here is the standard deviation. So sigma is 75 minus 60, which is 15. So standard deviation equals 15. All right. 3 has actually 3 questions to it, so let's take a look. Which of the data sets has the greatest dispersion? So that would happen if the data is spread out, and the data is spread out when your standard deviation is large, so that there is a large space between 45 and 60. It could be even larger if the standard deviation was, for example, 20, and then you would be going back 20 each time. So we're looking for the largest standard deviation. So that would be A. Which of the data sets is the most consistent? So that would be with the smallest standard deviation. And looking at my choices, that would be choice B. And which of the data sets has a normal distribution? So you can tell which one has a normal distribution because the mean would be equal to the median. So there's your mean, and there's your median, and look also your mode. So that would be C. Okay, next page. All right, Amy scores 82% on her math test in Mrs. Smith's class. And so this is Amy, 82%. That would be the X in your z-score formula. The average score is 75, so 75 would be the mean, and standard deviation of 4. All right, let's switch colors for Karina. Amy's friend Karina is in the same, is taking the same test in Mr. Jones' class. His average, so Karina has an average of 73. That would be the mean. And a standard deviation of 3. That's the standard deviation. So the question is, who did better in comparison to her classmates? All right, so we're going to find the z-score for each one. I'm going to start with the second one because I have the purple marker out. So z is going to equal Karina's score, so 81, minus the average, 73, over the standard deviation. Okay, and that's going to give us 2.67. All right, and switch on back. So this is Miss Karina for Amy. It's going to be X minus mean, so 82 minus mean over standard deviation, 4. Okay, and this one gives us 1.75. So now you can compare their z-scores. This is Amy, and over here we had Karina. And because Karina has a higher z-score, we can say that she did better in comparison to her classmates. So Karina, because she has a higher z-score. All right, what score does Karina need to get in order to have the same z-score as Amy relative to her class? So now we need to substitute into that z-score formula one more time. Okay, let's look at this. So we know z is equal to x minus mean over standard deviation. And we want, we want the z-score to be the same as Amy's, which was 1.75. So 1.75 equals x minus, but Karina's class had a mean of 73, and you want the standard deviation to be 4. Oh wait, 73. Standard deviation here is 3. you're going to multiply both sides by 3. And then you're going to add 73. So x is going to equal 3 times 1.75 plus 73, and I get 78.25. All right, now we need to practice figuring out permutations and combinations. So permutations, the order matters. If you look at the first two, you can see the difference between these two is that in the second one, the students that are selected all have a different job. So the order matters, which order I pick them in. So since the order matters, this is permutation, and here this is combination. Since these are 3 different awards, this is permutation. And since these are specific committees, this is also permutation. Okay, so we're done with pages 1 and 2, and we'll go to a new video for pages 3 and 4.